Alright, this time we have trigonometric functions that we will be starting on. I'm going to split this into two videos since these ones can get a little bit longer to go through and explain. So for number one, we have the terminal side of an angle theta in a standard position passes through the point -3, 4. Find the values of the 6 trigonometric functions of angle theta. So remember, theta is your angle measurement. That's what that is called. So here, if we're going to plot that point, we plot it just like we did before. We have our x, our y. Remember, your x-axis is the horizontal one. Your y-axis is the vertical one. So here, if we have -3, 4, we have to go to the left 3 and then up 4. And then we put our point. Once you have that to draw in your angle, we want to first go through and plot this point and connect it to the origin. So connect it to the point 0, 0. It's not going to be exact, but get it pretty close here because we are sketching it by hand, so it's not going to be perfect unless you're using a ruler or straight edge. And then to draw out your angle theta is measured from the positive x-axis, and it's rotated all the way around until you get to that terminal side, as it is called. This side, this line segment that we drew out, that's called your terminal side. So if we're trying to figure out our 6 trigonometric functions, remember that's your sine, cosine, tangent, cosecant, secant, and cotangent. And to use those, we're going to need to use the x and y coordinates along with our value r. So we already have what the x coordinate is, that's the -3, and we have the y coordinate, which is the 4. We need to figure out our r. So to figure that out, we're using that Pythagorean theorem again, where our r squared is the same as your c, that's the hypotenuse. That's going to be what the length of this right triangle is. So let me draw this in a different color here. So you can imagine that we've got this right triangle going on here where we have the right triangle formed from x and the y-axis there, and then the hypotenuse there is formed from the point -3, 4 down to the origin of 0, 0. So to figure out our r, we're going to need to do r squared is equal to our x squared plus our y squared. So the -3, make sure to put that in parentheses squared, plus our 4 squared. Since the 4 is positive, you don't have to necessarily put that in parentheses if you don't want to, but if it is negative, definitely put parentheses around it, otherwise you're going to get a different answer. So here then we've got a 9 plus 16. So then if you add those together, we would get 25. Don't stop there, because remember that is your r squared. We need what our r is. So remember, to cancel out a squared, you have to do the square root. So r is equal to the square root of 25, which is equal to 5. So make sure you do simplify your square roots if they can simplify by either going down to a whole number or taking out any perfect squares there might be, like we've done before. So then to write out your sine, cosine, tangent, and all of that, you're using the different properties in this section here. So for your sine function, it's going to be your y coordinate, which was 4, over the r, which was 5. So your sine has to do with the y coordinate over the r. And then your cosine has to do with the x coordinate. And in the lesson, you'll see I gave a little hint to help remember that cosine starts with a c, and c comes before s. Likewise, you have x comes before y. So the x goes with the cosine, y goes with the sine. They're both in alphabetical order of how you're plugging those in. So it'd be in terms of your sine and cosine. And then I'm going to write tangent down here because I'm going to fill in some other functions here below our sine and cosine here in a minute for the ones that are the reciprocals. So the tangent is going to be your y coordinate, which was 4, over the x coordinate, which was -3. So that would be in terms of your sine, cosine, and tangent, first of all. And then remember, we have our reciprocals of each of those. So the reciprocal of our sine function is our cosecant. So cosecant is going to be 5/4. It's the reciprocal of sine. Remember, reciprocal means you're just flipping that fraction. Your secant is the reciprocal of the cosine function. So that one's going to be a -5/3. You're just flipping that fraction once again from the cosine function. And then for the cotangent, that's the one that is the reciprocal of tangent. So that one would be a -3/4. Once again, if you only have one negative, it doesn't matter where you put that negative sign. It can go on the top, the bottom, or it can go out in front, as long as you only have one negative sign there. And then, like I said, we'll go through number 2 in the next video. But if you do have questions on this stuff, make sure to ask.